3.1 discusses reference angles. So this is just adding on to the stuff that we already know. Okay, a reference angle is an angle between 0 and 90 that tells you how close you are to the x-axis. Or I should say that I'm trying to think of this in a way that you guys will best understand. So it's the shortest distance to the x-axis. So what that means is you have 4 different quadrants, right? Go ahead. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in quadrant 1, like let's say I have an angle in quadrant 1, some angle theta, okay? In quadrant 1, this is, what is this right here? This is, what angle is this? This points out to what? What is this one pointing up? So this is 0. We start at 0, correct? This is what? 90. And then this is what? Not 270. 180. Bottom, not 360. 270, because you're adding 90 each time, okay? So, these are the different degrees. So these marks are important. Like over here, this is 0, 90, 180, 270. So in quadrant 1, this angle theta is already between 0 and 90, correct? So the reference angle is just theta. So it's just the same angle because it's already between 0 and 90. In quadrant 2, it's going to change because now let's say your angle is over here. Okay? So now this is your angle, theta. So now your reference angle, so I said, it says an angle between 0 and 90 that tells you how close you are to the x-axis. It's actually this part right here where I put shortest distance to the x-axis is correct. So the shortest distance to the x-axis is not this way, it's if you go straight down, correct? Like this distance here. This is your reference angle. So I'm going to use a different color to signify what the reference angle stands for. So here, the reference angle is going to be in blue. Every time we have a reference angle, it'll be in blue. So theta here is our reference angle because it just goes down here. It goes to from 0, it's already between 0 and 90. This is going to be between 0 and 90, right? Because it's in one quadrant. But how do we get that, right? So we take the whole half a circle, right? And what do? How much is a half a circle? 0, 90, 180, 270. So how much is a half a circle? Halfway around. 180. So we take the half a circle and we subtract what to get the blue? So we take the half a circle and what do we subtract? If you subtracted 90, you would get this. So whatever this is, which is called theta. So we subtract theta to get the blue. So the point is we want to get the blue. In quadrant 3, so we have 0, 90, 180, 270, okay? So an angle in quadrant 3 would be all the way over here. The shortest distance to the x-axis, you're correct, is going backwards. So is going up, right? This is theta. So this is our reference angle. Well, how do we get that? Close. So reference angle is going to be, so you first said, oh, it's going to be 270, but we have nothing to do with 270, right? Let's look at this big angle here. If we look at the big angle and the little angle, the little blue angle, what's the difference between the two of them? What do you have extra here?
180.
You have an extra 180, right? So can't we take the big angle, theta, and subtract how much? Because how much extra do we have? So if we subtract an extra 180, we'll get the little blue one. And for the last one, so now we're in the fourth quadrant. And that would be all the way around like this. Where is our reference angle? It's going to go up in the same direction, right? It's going to be this little thing here. Yep. This is the same as 0 and 360. No, that's just the way it always is. Okay, so now what do they create? The whole thing. They create a whole circle, which is 360, right? So if we took the whole circle and we subtracted what, how do we get the blue one?
From theta.
Okay, so we take the whole circle, 360, and we subtract theta, and we get the little blue angle. Now, the reason why we have reference angles is because all trig functions you can find, let me rephrase this, you can find any trig function and relate it to the trig functions in quadrant 1, you just have to change the sign. And we'll look at that in a second.